I here? My name's Keegan. Some of you might know me as JPEGleg. And I'm here because I am a content developer at Offensive Security who has been focused on cloud security and creating new types of content for OffSec and for all the learners. I've been involved in the finance industry and the medical industry for well over a decade, and I'm bringing a bunch of that administrative and operational experience, as well as blue team experience, to our training materials as we develop new kinds of training. So that's a little bit about me and why I'm here. And yeah, let's jump right into it. So the cloud security is a new area for offensive security. And so in the last year, we've been building up some new materials. And what you're going to find is that we have more and more materials coming out related to cloud security. What we have right now is a collection of essential materials that we categorize under CLD 100 currently in the platform. And these materials are not just about offensive security. They really are a blend of attack, defend, and build. And the purpose of these materials is to build a strong foundation for our cloud security journey as we learn more about cloud security, whether you are a pen tester, whether you are a red teamer, purple team, blue team, DevSecOps, site reliability engineer, security engineer, cloud security architect, sysadmin, or a developer. All of these different roles can benefit from this essential cloud security training. So what is in this material? We have theory, and that's not as common in a lot of the OffSec material. We have some theory in this material, and part of that is for the cloud architects and the cloud architecture students out there. But it's also beneficial as we think from an adversarial perspective to know some of the theory behind not only the human processes, but also the systems designs, as we begin to think about how an adversary can take advantage of our cloud systems. Understanding the theory enables us to really work within that space more effectively. So not only does that build up our adversarial thinking, but it also helps us as developers and DevOps to build smarter, build with security in mind from the very beginning. So we have some theory. We also have a lot of coverage on core tools, these essential tools that you will find yourself using in different professional settings, whether that's an engagement against attacking cloud infrastructure, or whether that's your day job as a developer or as an administrator. So some of these core technologies is Docker, as well as Podman. We have labs for both of those. And we're not just going to make a Docker container. Some of the training that you might see elsewhere, you learn really basic how to make a Docker container and deploy it. We go further than that, and we really seek to help our students understand fundamentally what are the components of a container. How do these container systems, OCI containers, actually contain an application and processes? So we have labs that break down some of these components and allow you to explore and hack on individual pieces that make up an OCI container. We also have Kubernetes labs. So, and it's not just Minikube. It's not just one implementation of Kubernetes in our introductory labs. We have Micro K8s, we have Minikube, we have vanilla Kubernetes, we have K3s, and you can explore all of these different implementations of Kubernetes, as well as learning some of the concepts around how we think about Kubernetes, as well as some of the weaknesses we might find in Kubernetes. We're also studying a number of things in the CLD 100 to support our knowledge here, from Git, YAML, JSON. We have a lot of prerequisites for cloud security, Linux, networking, scripting. We need all of these things. So that's what CLD 100 is for, is getting all these prereqs and base understanding together, so that as we go into attacking cloud infrastructure and defending cloud infrastructure, we have a familiarity with some of the main constraints, designs, tools that we will encounter as we go. So beyond the prereqs, one of the things that students in CLD 100 are going to gain is understanding the primary weaknesses and essential security flaws that we are going to see time and time again in naive cloud implementations and configurations. These are things like credentials and credential management. There's an increasing amount of sloppy credential management in cloud usage, and that is a huge weakness for security. We're also going to explore areas like exposed Docker sockets, and how essentially if Docker is running in a default way as root, if a user has access to Docker, they can root that system, and or more than likely can root that system. We're going to explore areas about different types of credentials in Kubernetes, how powerful a cluster admin credential is, and how difficult it can be to recover for a defender if a cluster admin credential is leaked. We're going to explore areas like Kubernetes dashboard and some of the risks that may come up from exposing a Kubernetes dashboard. So these are all very common problems that we see across the industry, and we get a hands-on experience exploring those problems in CLD 100. So that's a little bit about CLD 100 and the benefits that we as learners gain from going through CLD 100. We also have a lot of mixture between attack, defend, and build. This is different than some of our other materials. CLD 100 students can benefit from offensive perspectives as well as defensive perspectives as well as build perspectives. And they're all mixed together in CLD 100 to benefit a large range of different types of students, not just pen testers. So right now we have a nice collection of 12 learning modules. And one of the exciting things about CLD 100 is that we have new material coming, not only at the 100 level, but also beyond. And we have some completely new types of labs that have never been seen before at OffSec coming in the near future. So keep an eye out for new labs, completely new lab experiences. There's a lot of exciting engineering work going into building out new types of labs. All right. So that's a little bit about kind of crashing through the material, what it's all about. Today on the call, I'm going to demonstrate some of the labs and also take an opportunity to provide a few lectures that are not exactly in the CLD 100 material, but supplemental to the CLD 100 material. So first, let's, before we get into the lectures, let's take a look at CLD 100. And let's see if I can share here. All right. Let's go over here. Okay. So here I have the OffSec learning platform pulled up, and just to show everyone where we are in Introduction to Kubernetes 2, part of our CLD 100. And here is where we have a number of labs for Kubernetes, including a multi-node Kubernetes lab. This is one of the things that you'll find many other training experiences lack, is the ability to play with multiple nodes. So we're going to use in-browser Kali, and let's see if everything's running. Okay. So let's go ahead and go make a Kubernetes cluster in our lab. Okay, I'm gonna SSH in there. Okay, oh, that's a comma. All right, we're gonna become root. So we have step-by-step instructions to join a default cluster. We also have this script available, lab join. So we're going to run this script and form our cluster. Right now, if we do kubectl get nodes, we've got no cluster going on right now. Do lab join and form our cluster. While that runs, minimize that. So as you can see here, we talk about a number of different concepts that are really important to starting to use Kubernetes. We aren't to the point in this progression, this path of truly securing Kubernetes or truly attacking a realistic Kubernetes, hardened Kubernetes cluster. But what this material does is get you using Kubernetes and thinking about areas that have common problems. One of the immediate areas that we should realize right away here is that the default credentials here that we just put in .kube-config, this credential here is extremely powerful and is not scoped properly to just a subset of the cluster. This credential has full cluster control, and it's in plain text on the system. And we see this in the real world. We can harvest this file here and have full root equivalent access to entire cluster, not just one system, but an entire cluster of Kubernetes systems, be able to exfiltrate and manipulate data. So as a defender, we need to understand how severe this is and protect these configuration files. And as an adversary, we need to think about gaining access. How do we gain access to these cluster administrator level credentials? Okay. So now that we have our cluster bootstrap, let's take a look. kubectl get nodes -o wide. Let's take a look. Increase the size there a little bit. All right, so we have 3 nodes. We have 1 control plane node, and we have 2 worker nodes. We're using Kubernetes version 1.23 in this lab. And some people think, oh, well, that's kind of old. The important thing is that many clusters are not actually at the newest version of Kubernetes. And if you take a look at the managed clusters like an EKS cluster or different common clusters people are building, this is a current version that they are offering, and many people are selecting several versions older. Every few years, or as needed, we will update the versions. So it's one of the benefits of the CLD 100 material is we will maintain it over time and continue to provide version updates and changes as technology changes for the cloud ecosystem, cloud landscape. So we've just assembled a 3-node Kubernetes cluster, and this lab, although it's an air-gapped network, you can't reach very many places here. We were able to get to google.com with a ping, but we couldn't update this cluster correctly. So we have a limited network. This is useful also for build students that are trying to prepare for operating Kubernetes in a more air-gapped or limited network environment. A lot of the online trainings that are out there today, they're exposed to the internet, and it's not usually like that in an enterprise network. We have firewalls and limited networks. So what does it take to insert a container into a cluster in an air-gapped network? And that's something we will be proficient with by the time we've finished going through our CLD 100 materials. So I see in the chat, what is a Kubernetes? Can someone explain? All right, so let's back up for a minute and talk about that. So Kubernetes is a community. It is a project for distributed computing. It's a large open source project, and some will call it a container orchestration system. But the truth is that it's more than that. And the reason it's more than that is that rather than like orchestration, you're going to have steps of things that need to happen. You're going to say, okay, well, I'm going to orchestrate this. I need this step and this step and this step. Kubernetes, we actually declare a state of a group of computer systems that we call a cluster. We declare a state, and Kubernetes takes that declared state and tries to make that happen. It's truly a beautiful thing. We can have thousands of computers join together as a cluster, just like we join these three together as a cluster. And we can declare, I need these applications, these security controls, these networks, declare the state of the computers. And with the Kubernetes API, we're using kubectl, which is our API client. We're going to use that to interact with the control plane, which has our Kubernetes API. We're going to declare the state of our systems. So let's do that right now. So kubectl, and we're going to do a create -f, which is going to say we're going to pass in a directory or a file. We're going to go var lib, and let's do production initial. So what's in here are a few YAML files, and 2 YAML files, and all they do is create 2 Kubernetes namespaces, one called green and one called blue. Okay, so we will apply them. We used a create there. So now we have 2 namespaces created. Let's go on to do a create on this set of 1 deployment and 1 service into the blue namespace. Okay, so create will make something new. If I run a create again, it's going to say, oh, that already exists. But what we can do is we can use an apply. And apply will do a create if it hasn't been done. And if there's no changes, or if there are changes, apply will handle that gracefully. We still had some warnings there, but we can apply any number of configurations, 1 line, 1 command. And so now we can inspect our containers that we've deployed. kubectl git pods. We're going to do -o wide again so we can see, and we need to either declare a namespace or say all namespaces. We use the blue namespace. So we're going to say namespace blue. And here we go. We have 2 containers. These containers we'll be playing with throughout CLD 100. Some of the containers we'll be playing with, we'll play with Nginx. Nginx is an incredibly popular container. We also have a Python Falcon ASGI service that does encryption and decryption with Salsa 20. So that's a fun one to play with. We can encrypt data with that service, and so those are 2 of the little services that we will be experimenting with as we learn. So what are we looking at here? For those of you not familiar with Kubernetes, what are we seeing here? This is a pod. A pod is something in Kubernetes that holds 1 or more OCI containers. And a pod is a declared unit. It's an abstraction in Kubernetes. And the containers within a pod will show up. You'll see how many containers you have in a pod here. Many pods just have 1 container. Some have 2, some have 3. Containers within a pod can communicate as if they were in the same network loopback. So they can communicate to each other. They're considered one unit. Okay. And so if we have two containers, we're going to see the two here. And if we have both running, 2 out of 2 containers running. We have status running. And then since we did the -O wide, we can see the nodes that Kubernetes put these workloads on. So we didn't say send one over here to this one and one over here to this one. We simply declared Kubernetes, I want 2 of these, each of these pods with the 2 services in, create that. And that's one of the beauties of Kubernetes, is that we can declare a state, and then Kubernetes works hard to solve the packing problem for us. It's going to put resources onto nodes. We don't have to individually think about putting some over here, putting some over here. How do I, deploy these individual containers across these thousands of servers? Instead, we can have a YAML file. So let's take a look at our Blue deployment that has our containers declared. And so this is a single deployment, meaning that these containers will go in the same pod here. Okay, so we have an Nginx container and we have our prod Falcon container. Okay, so that's a little bit about what Kubernetes is, for those that were asking in the chat. There's a lot to Kubernetes. And if you're interested in learning more about Kubernetes, get in there to CLD 100 and try it out. There's a lot of knowledge that we are sharing, even at this essential level. So we can play around in here in these labs and get familiar with the different types of Kubernetes implementations. And let's go ahead and let's exit this lab for now. Go look at some of our other materials and where to find our CLD 100 materials. Let that stop. Okay, I'm gonna go ahead and close this out. So for those that haven't accessed the CLD 100 materials, go to courses and then cloud security. So this section right here, this is where we have CLD 100. And we're going to continue to add more and more learning modules here. And then also in the near future, we're going to have more 200 level and beyond cloud security learning modules, where we're going to defend Kubernetes clusters, we're going to attack Kubernetes clusters, as well as different types of cloud infrastructure and cloud systems that are common today. So we click on CLD 100. These are the 12 learning modules we have in production today that are available. As you can see, we start off with an introduction. We have this cloud architecture overview, and this is some of the theory that we have published right now. A lot of it has to do with systems design. What is a cloud? And how do we start to think about cloud computing in a way that's not just marketing hype, right? It's not just the cloud, and it's not unhackable or perfectly secure. That's one of the important things that we learn, not only as adversarial thinking professionals, but as build and defense thinking professionals, is what really is happening when we're talking about somebody's cloud configuration, cloud instance. What's the reality of this? Let's throw out all the marketing hype about how ideal something can be. Let's really look and really examine what it is that we're dealing with. A lot of it comes down to a cloud system is distributed computing, and it's abstracted. The infrastructure is abstracted so that the operator doesn't have to go create, go buy another rack server and hook it up and do all of the stitching glue work to get another piece of physical infrastructure attached to expand it. It's abstracted in that way so that we can work separately from hardware directly. Okay. And cloud systems also have the ability to kind of, with that, expand based on need. Our the bill's going to go up, but you can get more resources on demand. And that's an important part of what a cloud system is. So we need to have multiple geographic regions for it to be a good cloud, to be a proper cloud. And that's a really interesting point that a lot of people don't realize initially, is that you can use AWS in a completely non-cloud way. They're a public cloud provider, but you using them isn't inherently a cloud system. You can, for example, create a single VM and a single availability zone, and that's not actually a cloud. You're using a cloud provider, but you've just created a non-cloud system. So this is really important for our cloud architects that are getting started on their learning journey. This is really important for our SRE and DevSecOps students that are beginning to study cloud. Is how do we design these things so that it is a proper cloud, and that we do have distributed processing across multiple regions, and ensure that it can grow, and start to think about the security flaws. We've talked about it a little bit, but again, we can make a fairly secure microservice and put it into a cloud provider and go, look, we've made something that it looks really nice on paper, and objectively is well done if you look at just the microservice. But a lot of the weaknesses and the vulnerability in cloud systems is not from the application that you put into the cloud system, but about how the overall cloud system is administrated. And the edge systems that have access to the cloud infrastructure, these edge systems are often going to have plain text credentials, just like that file I showed you earlier in the .kube directory, the config file, plain text credentials sitting there that have a lot of power over the entire cloud or cluster. And so that some of these things are part of the thinking that we are helping our students prepare for, is zoom out, think about the big picture and the whole attack surface, not just within the cloud, but how members of an organization are supposed to interact with the cloud. Where are those credentials stored? Is that credential in a compromised password manager? Is it in plain text on someone's desktop where an adversary can pivot? Maybe someone clicks a phishing email, they get the credentials, and now all of a sudden they can pivot to your entire infrastructure if the right credentials are exposed on that end system. So that's the architecture overview, and we're really trying to reveal a lot of what we're going to be learning about in the future, as well as in the CLD 100 group. Then we get into the containers modules. These modules break down what a container is in terms of an OCI container, but also the history. Before we had OCI containers, we had other container mechanisms, and it's not enough to just Docker run, Docker build. We need to understand these constraints of the OCI container. what is a C group, a control group? What is a Linux namespace? And what are the boundaries of those components, and how do they work together to containerize an application? So we have hands-on labs where we get to explore many of those elements. And then we've got an offensive lab here, discovering exposed Docker sockets. That's one where we can practice abuse and exploitation of a Docker socket. Again, that is a really common mistake and a blatant weakness in many systems, is that the Docker access is given to a lower privilege user, and that lower privilege user then is effectively root. And especially if you expose that Docker socket on a network, you may have just exposed root access to that system. Okay. And so that's a little bit about what that one's about. We also have this module about encoding and serialization in here. And this is one not to overlook, because a solid understanding of data serialization and YAML specifically is very advantageous in the world of cloud computing. We have a lot of work that will exist in YAML files. So as we move on to more advanced cloud hacking, we will be using YAML spec. We'll be using and abusing YAMLs to then create API requests which manipulate cloud infrastructure. Okay. And we get into that a little bit in Kubernetes as we start to learn how to interact with and create specific states. We're going to challenge our learners here a little bit more than maybe what they're used to, and demand in the challenges there that the learner is able to set Kubernetes, declare a state based on a prompt. So we're going to say, do these things, make a state with these very specific values. And the reason why we are challenging our students to create a cluster state is that is not only our goal as builders and defenders, but also as adversaries in cloud computing. We have to understand the declared state of a cloud system, the state of a system, and how to manipulate that state to exactly what we want. Whether that's we're going to insert a C2 container into some cluster, into a namespace. We have to know how to manipulate these cloud systems if we're going to attack them, as well as if we're going to defend them or build them. We have a little bit of exercise here in the next one, another offensive module where we're going to hack on Kubernetes dashboards. This is another common mistake, is that people will leave these dashboards in places that are inappropriate, perhaps exposed to the internet, or even exposed to a network segment. And one of the things that we can see with many Kubernetes dashboards is that they allow you to skip authentication right here, a built-in bypass. So there's many types of things we might encounter with Kubernetes and with cloud systems that aren't exactly secure by default. And so we want to know where those things are. And that's part of what we're doing in this group of materials, is pointing out these areas where there's likely insecure defaults, and special attention should be placed there. So as a pen tester, we can look for all these things to make sure that they didn't leave this, where you can skip authentication. And as a builder or as a defender, we know to harden those things and remove those insecure defaults. So question in the chat, how to save credentials then if not in plain text? Well, that's a really good point. So there's a lot of different things that we might do depending on the scale and how many people are involved and what the budget is. But one of the things we can do is we can store those Kubernetes credentials in an encrypted vault of some kind. And whether that's just an encrypted file on the system that then maybe requires some kind of attestation or a token to decrypt to then use, or perhaps the config, the admin config is locked away remotely and no one gets to use it. And we're going to delegate role-based access controls with a smaller scope and not even give them to people. Keep those Kubernetes credentials away from individual people, put them in automation systems, and have people then authenticate into an automation server where they can then trigger the automation that uses a role-based access control account. So that's a little bit about how we can improve getting those credentials away from users and then locking away your admin config so that no one gets it, and having much smaller segmented role-based access controls built into automation systems. Okay. So let's see here. Keep cruising through some of this stuff. The last few modules here we have are about Git, and that's important knowledge as well as we prepare ourselves to interact with a lot of these cloud systems. I was just talking about automation systems, and that's a common pattern we see now is a GitOps based system where we've removed the direct access completely to the infrastructure from most of the organization, and instead we have them interacting with Git repositories. So the YAML for the declared state can be pushed into Git, and then the automation system can use what it received or found in Git and declare the state. And then the user can observe the results through a dashboard or through interacting with a product directly. So understanding Git's not only important for our builders and defenders, but also for our adversarial thinking. As we, if we gain access to one of these systems and it just has Git access, it doesn't have the Kubernetes admin credential, but we do have Git access. Well, now, as an adversary, we might be able to manipulate their cloud infrastructure via Git commits. And so Git usage is important for all of the roles, and we will be building on this in later learning modules related to supply chain security and attacking and defending GitOps based systems. Okay. So that's a little bit about our CLD 100 learning modules that we have today. Again, we are going to continue to release new modules that expand into more areas of cloud computing and cloud computing training areas. So keep an eye out for those. Does anyone have any questions or areas they'd like to explore here in the last section of the stream today? Feel free to comment in the chat. If not, I will pick another lecture segment. Okay. All right. So I will jump right into another lecture area. So one of the things that is important right now in cloud computing is this concept of zero trust architecture. And we're going to introduce zero trust architecture in CLD 100 in that architecture overview module. We introduce ZTA, zero trust architecture. We don't build ZTA in CLT 100 in a lab, but we're building up the knowledge about what it is conceptually and some of these components that that we have to deal with. So what is ZTA? Zero trust architecture. When we first hear about this term, it sounds impossible, right? This idea that we're not going to trust anything in the architecture. And many people are still confused over this area today, and marketing people take advantage of it, and they just call all sorts of things zero trust when they're not actually zero trust. So from a practical standpoint, what are we really doing when we're designing a zero trust system? Well, I will distill it down to the most fundamental aspect here, is that for every resource request, we need to ensure that that request has been authorized. And that authorization process is actually something that we can't truly distrust in zero trust architecture, which is confusing to people. And one of the things that's kind of swept under the rug is the authorization process itself. What I mean by this is that we're going to segment all of these microservices and applications and systems so that every single one requires authorization. Even if you're in that network, if you're in that network segment and it's right there, 0 hops away, we still need to have a mechanism to authorize access. But what's happening and what we're seeing out there is that people and organizations are creating centralized authorization processes, whether that's multi-factor or not, but creating a centralized authority that is authorizing all this individual access. So now, as an from an adversarial perspective, if we compromise that central authority, we have everything. We have everything. And so the flaw of many zero trust architectures is that it does trust the central authority that's used for authorization, and control over that centralized authority can be completely fatal to the entire access controls over a zero trust system. So what can we do from a defense perspective to improve on that? One of the things we can do is we can create multiple segments or scopes of authorization. And this is something we will potentially explore in future materials in more depth. But in summary, if we scope authorization so that, for example, development backends all have one scope of authorization and it's centralized there, and that system is separate from the production system, that separation of scope of authorization, that segmentation can be very helpful. It means that an adversary that's able to exploit one point of your centralized authorization system is only going to have a certain scope that they've compromised rather than everything. So that's one of the flaws. Thinking about how we approach zero trust architecture and beginning to iterate and improve our zero trust architecture is a very important task for a lot of us on the build and defend side. And we're building up skills working towards improving our cloud architectures and cloud security models. So that means micro segmentation, meaning we're going to write rules and declare, just like in our Kubernetes manifests and other systems, that the smallest amount of access, the most granular amount of access we can. And we're going to require authorization for every resource request. One of the other common flaws in zero trust architecture is that there's all this work that goes into making the segments and making the authentication process that gives the authorization. The authorization needs to be short. So this is a critical piece, is that the validity of the authorization should be the smallest time window as possible, meaning that the access granted based on a successful authentication should be, maybe 30 seconds or less, ideally. Sometimes it has to be more, but the smaller window is better. So in order to do that, we need certificates and tokens that have an expiration value. Well, if we're giving out tokens and we're giving out raw tokens that have an expiration value in there, an adversary or just a lazy developer could take that token, edit the token, edit the expiration value, and reuse that authorization over and over and over again. And so the malleability of tokens is a really common weakness, and something that can also be fatal for a zero trust architecture design. And so what do we do about that? What do we do about these tokens that could be edited? Encapsulate those tokens, wrap them in a way that makes them tamper-proof, tamper-resistant. And that could be with, for example, additional layers of cryptography. Perhaps we're going to encrypt or sign the entire token, and the system that receives the tokens ensures that it's not been tampered with by validating its signature and making sure that that is an expected token. So that's a little bit of information about zero trust architecture and zero trust architecture weaknesses that we can begin to think about, not only from an adversary perspective, but also as a defender and as a build student. How do we improve these systems so that we don't have the single point of failure, we don't have the malleability, plain text credential abuse? All right, we're down to the last few minutes. Let's see here. Take a look at the chat. How much networking and processing overhead does a viable, well-constructed ZTA add to the system? It can add a significant amount. And that's another challenge in ZTA, is we may be doubling, we may be tripling, in some cases, the compute resources needed to carry out a task. And as I mentioned, if that is poorly implemented, it's even more vulnerable than it was before. Okay. So zero trust architecture is a big task to implement correctly. It's a lot of work. It can be very expensive. It could be computationally expensive. The end result, if you do it well, is really great. Does it solve all the problems? No, it doesn't solve all of the security problems. It helps a lot. It helps if you have vulnerable application, a microservice gets compromised, it's pretty well trapped within its scope. And that's a beautiful thing. Rather than in maybe a classic network, if we have an app that's compromised and adversary gets into that microservice, they may be able to move laterally across the organization and gain access to more resources without having to steal someone else's authorization or compromise the centralized authority. Any other questions or thoughts? Will CLD 100 prepare me to future harder OffSec courses as someone who does not know anything about how cloud works? Absolutely. That is why we made it. This is your stepping stone into cloud security, as well as getting familiar with the tools necessary to interact with these cloud systems. Absolutely. That is why we made this. And you can consider it a launching pad for your cloud-related career, not just pen testing, but all kinds of cloud-related roles benefit from this knowledge. Okay. Last couple minutes here, if anyone else has questions. All right. Yeah, happy hacking, everyone. I hope you enjoy the CLD 100 materials. And now is the time to get prepared for cloud security, up your skills, get more familiar with how containers work, how Kubernetes works, and be persistent. Some of it is more challenging than you expect. Takes a different perspective, but once you've gotten through it and you've got a good grasp on these core tools and these designs, your next engagement where you have to interact with a cloud system, or your next Jira ticket at work where it relates to a cloud system, will be much easier. And as I said several times, stay tuned. We have a lot of new and exciting labs and learning modules coming in the near future. So thanks, everyone. I hope you had fun listening to me talk about CLD 100, and happy Friday.